everyone. Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I'm joined by my co-host,
Ben Wilson.
And today we have a guest that I'm very excited to chat with. His name is Manu. Manu is currently a staff data scientist at Walmart, but in prior roles, he's worked as a supply chain consultant and headed an applied research team that focused on causality and prediction. So, Manu, one of your more recent projects is PyTorch Tabular, and it helps you run PyTorch on tabular data, which is a giant surprise. So, what is tabular data, and why do we need your library?
Right. So tabular data is the most popular data that you find in the business. You'll find Excel files, SQL tables, any relational databases. It's all tabular in nature, right? You have like columns and rows, right? That's tabular data. And whenever we think about tabular data, at least from the ML point of view, the most obvious choice is gradient boosting models, XGBoost, Light GBM, and things like that. But what kind of led me to this kind of a niche is that in my previous organization, I was working with a lot of different businesses, and then most of the use cases are tabular. So we always go and hit the Light GBMs and XGBoost of the world. And I was always kind of thinking, is there something other than this that we can do? And that's how I started looking into this area. And I realized that like deep learning did a lot of wonderful things in image domain, in text domain, like even in the graph domain. But tabular, not really that much. But as I went deeper, right, I did realize that there are some research happening in the area. Like people are working on kind of trying to push the boundary on in that area. But usually what happens is all of these is like although the researchers release the code bases, it's not really user friendly. Like it'll take a lot of engineering on your side to make it work. So that's when. So basically, I just started this as a like a personal project. I was just trying to make sure or trying to kind of run a few of these different models on the data that we have. And once I started doing this, then I realized that there are people who want this kind of a thing, or like something other than gradient boosting models to work with tabular data, and that's why I decided to kind of open source it because it's in a good form already, and it was easier to open source. And one of the main motivations behind that is also to kind of help accelerate research and usage of this in the space, right? Because gradient boosting models and all of these other like brilliant scikit-learn libraries there, and it's like the most easiest library that you can use, right? It's very user friendly, but there is nothing of that sort when you move to deep learning for tabular data. So I wanted to make something which is easy to use, accessible to folks, even without a lot of software engineering background. They can start using something a little more advanced, and that's why I basically started this. And then as and when I started it, I think during that time, right, a lot of other like specialized models for tabular data came out, which in their research papers they show that it's better than the XGBoost and Light GBMs of the world in some data sets. So I thought, why not have like a unified API with which you can like use all of these models, right? You just need to switch out a class, just like you do with scikit-learn. You switch out a class, and the rest of the API works fine. So that was kind of like the design that was taken, and then right now the library is in that shape. Just a couple of weeks before, I think I launched another major version where I've also included self-supervised learning as another pipeline because those are things like areas where your standard supervised learning, it's very easy to do with your classical machine learning methods, but this like these kind of niche use cases are not really straightforward. So that's where probably deep learning and the flexibility that deep learning kind of brings to the table makes a lot more sense. So I thought let's start that kind of a push as well. So there are already a few models in the out there which have dabbled in self-supervised learning for tabular data. So, but I started something very basic like a denoising autoencoder. But there are other things like Tabnet. Tabnet also has a self-supervised one, and subtab, and like the work in this area is actually pretty interesting. So yeah,
So, to help our listeners or viewers out a little bit, uh, to break it down from the nerd perspective, when we're talking about these traditional ML algorithms, you mentioned like GBM, XGBoost, scikit-learn, anything that is a supervised training model where you're saying, I have this data in this training data set. And that's how people, data scientists typically think about it is like, hey, I have train DF, I have test DF and validate DF, of like pandas data frames. Uh, the ingestion that's happening under the covers of that pandas data frame, which is nothing more than a collection of series, like basically NumPy series objects. Those objects get vectorized in order for more easier to communicate with the underlying algorithm, which is usually written in C. So that vector of strongly typed data goes down into that. Why can't deep learning? I mean, I know the answer to this, but from you to the listeners, why can't deep learning process that vector? How does it need to think about data? And why does it mean that if you use PyTorch vanilla and trying to push supervised learning mode into that, why is that so complicated?
right. So yeah, if you ask me if it is possible to do it with bare bones PyTorch, absolutely yes. But it requires a bit of software engineering because it's not just a model. You need the data to be in the form of a data loader or a data set, which in turn goes into a data loader, which batches it. So each tabular data would have its own kind of way of doing it. And because it's tabular data, there's going to be a lot of pre-processing involved. Like you'll need to normalize some things, and you'll need to, if there are categorical variables, right, string variables, then you'll need to encode them, in a particular way. There's a whole lot of software engineering part which happens before you can start training a model. And even after you start training a model, you still have a lot of hurdles there because training a model on a single GPU with a single kind of a loop that you have, it's very straightforward, but it's not scalable. But when you move to multi GPU systems or distributed cluster systems, things become quite complicated. So what PyTorch Tabular kind of does is it sits on top of or the shoulders of giants like Pandas, PyTorch, obviously, and an excellent library called PyTorch Lightning, which basically kind of encapsulates everything related to the training aspect of this. So what PyTorch Tabular kind of really allows you to do is to like really get away with just defining a basic set of configurations, right? I'm just telling the library that, okay, this is my data frame. I have these columns. These columns are, say, continuous. These columns are categorical. This is my target. Whether I want to do some transformations, target transformations, or some normalization, just like set the config and just start running the whole thing, right? And another thing that the model or the library kind of tries to do is to kind of set intelligent defaults so that even somebody who is not really kind of deep into deep learning can start doing this right away. Yeah, because the most basic thing that the library just asks you to do is that you tell the library whether it's a classification or a regression task. You tell the model what the target and what the columns that you want to use, but that's it, and which model you want to use. The rest all is like you'll get something out of it. I'm not saying the best out of it, but you'll get something out of it. And then, as always, it's up to the user to kind of make it the best version of the model it can be.
Yeah, and if any listeners want to follow on with what Manu is talking about in answering my question, uh, check out their GitHub repository. In the example section, you can follow along in PyTorch Tabular example where it breaks down what he's talking about. Like you have a data configuration object that you instantiate, a trainer configuration, which has a lot of options that you can override. So it exposes a lot of the internals of how PyTorch functions about, what is your early stopping condition? What are you trying to optimize for? How often are you going to be doing checkpointing, and how many epochs are you going to run, and what your batch size is? So you can configure all that stuff with PyTorch, but you also get into that embedding configuration in a simplified manner instead of having to, which is personally in my ex history as a data scientist, ML engineer, I used to hate doing I love the creative part of feature engineering work where you look at the raw data and you're like, what insights can I glean here? How can I, generate something that's going to make a lot of sense? But I hated the process of doing manual encodings because it's boilerplate work. You're just doing the same thing over and over and over. You can get fancy with writing a bunch of functions and classes and, doing stuff like that, but you're just re-implementing something that should be a library that you can just call. So that's basically what this is. It removes all of that annoying work, and you can just focus on getting that model to train. So good on you. It's a cool project.
Yeah, there's one more thing to add here is that the latest version that I kind of released a couple of weeks ago, I've modularized it further so that if you don't want to use the training part of it, or if you don't want to use the model part of it, just the data part, data module kind of thing, that's also possible, right? You just need to use that part of it, and then the rest of it is your own. You can even bring your own like bare bones PyTorch model with a very simple condition that the input should be in a dictionary format with some specific keys, and that would start working with this whole setup pretty quickly. So I just try to make it a little more like less shackled by a little bit kind of like predetermined kind of templates, and make it a little more freer to use, which is also something that is like I always love to do that always. Because whenever I
Nice.
start to use a library, one of the things that always kind of irks me is that kind of there are some certain rules that I want to follow to make this work, right? So the less rules there are, the easier my experience in using a library is. So that's what I'm trying to do with that the PyTorch Tabular as well.
And that's the real balance when you're creating open source packages is, I think when people get into the process of coming up with an idea and they want to release something out there, if they're experts in that domain, hopefully they are, of what they're trying to build for open source software, you tend to want, if you've never worked as a software engineer before, you tend to want to just open up all the knobs. Say like, hey, I made this configurable, so it's an argument in the main method. And then you look at the argument list and you're like, hang on, there's 400 arguments in here. I'm pretty sure that violates like PEP, most of the PEPs that are out there. But it becomes overwhelming to a user. And even if you're sitting there putting defaults in, what does your PyDoc string look like? You do like help method, and you're like, hang on a second, it's printing out 37 pages of text. Nobody's going to read that. And if your PyDocs get generated in read the docs.io, nobody's going to scroll through that generated, RST HTML file. So it becomes daunting to a user when you're looking at that. You're like, this is scary. There's too many things for me to tune. And the alternative of that is, okay, the other extreme of that is I'm handling everything for you. So you'll be appealing to the novices who are like, hey, this is so easy. There's only 2 arguments. I just pass my data in and the names of my columns or something. And that becomes a black box that no advanced user wants to use, because they're like, hang on, I can't even use this because I can't override these things that are critical for my task that I'm trying to do. So I like the approach that you took in this library. It's very similar to ones that we do at Databricks for open source software, where it's like, we default a bunch of stuff. We also expose it in a configurable manner that, an advanced user can override it if chosen, but we try to limit the scope of complexity, even for the advanced users. So you're like, hey, yeah, there's 400 things that you could change here, but in any given project, you might only need to change 12 of them. even as an advanced user. The rest of them, the defaults are fine, but your next project might be 12 different ones that you need to change. So it's an intelligent, good design that you came up with, in my opinion. So definitely
Thank you.
people check it out. It's cool.
And then I had one question for both of you, actually. So PyTorch Tabular currently gets about 2,000 downloads a month. It has 820 GitHub stars and overall 14 contributors. So, what are your guys' thoughts on sort of the stages of adoption for an open source library? So, obviously, stage one is build version 0. But from there, how do you get contributors and how do you get users?
You go first. I'll have a different
Yeah.
nuanced view on this one.
Yes, that's a tough question, Michael. So I don't know. I haven't really thought about it that much because it's just the one open source contribution or open source library that I was there from the beginning till now. And in that journey, I know basically I kind of launched it, then gave a little bit of publicity in my LinkedIn profiles, and like there's a little bit of popularity that came from my colleagues who talked about this to other folks, etc., etc. Like kind of organically. Um, and I don't know, at some point, I don't know, there was some inflection point after which it kind of took off. I mean, I wouldn't say took off in a big way. It is still only 800 stars, but it kind of took off a little bit after a while. I actually exactly don't know what happened at that time. Um, and and I think probably also the one of the things that kind of makes it popular would be like if I have to kind of, since I am starting this library or putting it up, right, I'll also have to make this things easy to use for people. So enhancing the documentation, making a good README, and kind of putting some sample notebooks or something, some scripts out there so that people get started with it. That always helps. Um, and after a while, I don't know, the contributors and everything, right? It kind of came organically. Like, I didn't really run behind anybody to kind of get a contribution. It kind of came out kind of organically when people started using it, and then said that okay, there's some issue, or they said raised an issue or something. Then I said probably you might want to kind of raise a PR and then fix that. So that kind of gets I don't know, snowball into a little bit of a thing. And the 14 contributors, there are a few of them who made a lot of contributions in there, some structural contributions in there, and a lot of people who kind of raise issues or change documentation, add documentation. But I consider everybody, even if very like a if even if you add a comma in a documentation, I consider that as a contribution. So yeah, so everybody is a like that's a spirit of open source, right? It's yeah. So there is no formal answer I have on the stages because it's I don't know.
I think there's an optimal formal answer that if we were PMs, we would be able to tell exactly what that path is. I think it's still alchemy, though. There's so many factors that add into what your stages of development might be. So you could have 1,000 projects that hit version 0.1, which should be effectively your first release. It's like, hey, this is basically a prototype. We did our best effort of creating something that is hopefully usable, but consider that version and probably the next 5 releases as being your fine tuning, and hopefully not rewriting everything, but you're kind of listening to feedback. And that's what a successful project's going to do, is just going to be super friendly to the community. Anybody that's going to use it, get the word out there. And the bigger the splash of 0.1 to 0.5, that's going to be directly correlated to who you are, how many people know that you live on this planet, how many people know what you do on this planet, and what company is attached to your name or this project. So the larger that is, the more respect that company is, the bigger the splash is going to be. It doesn't guarantee that you're going to even get get from 0.1 to 0.2 though, even for the biggest companies in the world. We have very large tech companies out there that release prototypes just to get that feedback and understand, like, hey, is this something that people actually really want to use? People say they want to use it. Are we thinking of this in the right way? And sometimes you just scrap that and you haven't invested that much by that 0.1 version. But if the feedback is nobody cares, or people hate it, or they have so many things to say about how it should be different, cut your losses and go work on the next iteration from scratch and release 0.1 of that. And that's how you learn and iterate. But assuming that you are a big company, people respect you, they see your name attached to this and they're like, this is probably going to be good. And does it solve the problem that people have? Do people really need this? And does it not exist elsewhere? Are you building something that is fundamentally new and that makes people's lives easier in their work? If yes to all of those, then you're sitting on a gold mine. And provided that you handle the open source community with respect and friendliness and sort of open arms as a collaboration, the project's going to grow exponentially. Before you know it, you're on some advanced version of this thing and you're like, how many downloads do we have this week? Really? Look at the project that I'm working on with a fantastic team at Databricks, MLflow. We're looking at, we've long passed that 10 million downloads a month mark. And you just think about how many people are using this tool, and you look at how many people interact with the issues, and people just how many contributors we're having. I think we just passed like 550 or something. So project can do that. It can grow because it's hitting all those marks that it needs to hit. Not everybody loves it. You're not out there to make a project that everybody's going to love, but you actually want to get something out there where people are giving you negative feedback, because that means they care. So the people are like, this sucks and I wish this needs to change. That's great. Like, we love getting that feedback because it means somebody's passionate about the project. They really want us to fix this, or they hate this lack of feature so much that they're going to build it and we're going to help them build it. That passion is what makes for a successful project, in my opinion.
Got it. Yeah. Something last episode that you said, Ben, resonated with me, which is any feedback from a customer that is honest is valuable. So if it's good, great. If it's bad, great. The only way that you can hurt my feelings is if you lie.
Yeah.
So
I would actually add to that to say, if you were to award points to feedback, and this is universal in life, in my opinion, good feedback is worth 1 point. Bad feedback is worth 10 points. Invalid bad feedback is worth negative 10 points. And invalid good feedback is worth negative 100 points. So only listen to honest feedback that's good, but don't really put that much importance into it. The honest feedback that's bad, really listen to that. That is super important stuff that you should focus on. But people lying to you in a positive way, really ignore that. It doesn't matter. It's just an ego boost. You shouldn't care about that. And then lying negative feedback, just ignore. That's my take. Why?
Yeah.
If you focus on inverting the importance of positive feedback that's honest, and only focus on that, you're never going to innovate. You're never going to grow as a person or as an organization or as an open source project or whatever you're talking about in life. If that's all you focus on, you're just going to feel great about yourself and be like, I'm awesome, or my company's awesome. We can do no wrong. But if you focus on the negative stuff and not allow it to be a personal attack, but more of seeing it as hey, the only reason somebody's telling this is because they actually care. And that matters more than anything else. And I need to listen to this person who cares about this and do something to correct this. And that is what breeds innovation and change, a positive change and the growth of something, whether it be a person, a company, or a product.
Yeah, that makes a lot of sense. The way that I define, so one thing that I've been really interested in throughout my career is this concept of value. So what is valuable? What is not valuable? How do you find what's valuable? And then how do you deliver valuable solutions. And I'm still working on my definitions, but at least for insights and sort of decision science, I have a two-pronged approach that works really well. The first thing is that your insight moves metrics. So if we find some discovery that has no impact on any of our bottom line metrics or our North Star, it's not really valuable. It could be cool, it could be actionable, it could be interesting, but if it doesn't move a metric, it's not valuable. And then the second component is it needs to be actionable. So if you find something that, let's say, you're selling hot dogs, go back to the classic example, and you know that every winter solstice there will be this example's not going well.
Hot dog
Let's say
festival.
that, yeah, a hot dog festival. But that's an actionable thing. Like, you can plan accordingly. But the point is, if it's not actionable, it's cool. You can make a presentation about it, maybe make a commercial, something, but it can't influence your decisions. So I think that really resonates with what Ben was saying, which is you need things that are actionable, and positive feedback tends to continue inertia, whereas negative feedback can redirect it or even stop it. So that makes a lot of sense. And I think it differs greatly between fields for, let's say, decision science or product development or you name it. But that definitely resonates with my experience as well.
And I think both things tie into what Manu built, which is something that's not supported by the native package, the native library, something that is actively being researched. People care about it. And you just went out and said, I need to use this for my work. And why not be altruistic and give this to the open source community? And there's a bit of like selfishness associated with any open source because your name is on it and people are like, hey, this dude built this cool thing that we're using. So people know who you are. But it's also just giving something useful to people and seeing that organic growth that happens because people are like, actually, I want to try PyTorch with structured data because I don't want to go through the process of having to coerce that data that's sitting in a data warehousing table into something that PyTorch can consume. And a lot of people that are using these libraries now are, 4, 5, 6 years ago, people using, these popular deep learning projects. You needed some CS training to be able to do that. You look at, TF1.x implementations that were running in production. Look at that code. If anybody's out there that has some of it running at their company or people that have written it, you can't just be an applied engineer or applied data scientist to do that. You need to hit the books and learn some stuff and take some courses and understand, how do I manipulate tensors and how do I get this data structure from, not, maybe it's not in a data table, maybe it's not in a CSV, maybe it's a flat file that's just sitting there in some, super old encoding standard. It's like zipped, not even gzipped, it's just zipped files sitting there on object store. How do I get that into a format that, TensorFlow or PyTorch can consume this? You need some CS background. I mean, you can brute force it and write some crappy code and it'll maybe work, but to get it to be performant, production ready, you gotta do your homework or phone a friend and be like, hey man, I know you're doing software engineering stuff. Can you help me out with this problem? But nowadays, people don't need that skill set in order to use some of these libraries. Manu, you mentioned at the top of the podcast about people, a lot of supervised problems are using XGBoost and LightGBM. I would agree. At a lot of companies, that is the case. But some of the people that have been around for a while, who before those libraries existed, before scikit-learn was even really a mainstream thing, you're using lower level libraries. You're using stuff that doesn't have a lot of traction these days. When's the last time you saw stats models in production where somebody's building a regressor from scratch? Like, yeah, there's APIs to help you out there, but look at the number of options available for tuning that thing. You have to know that library. You have to know the math behind it in order to build something with that. But a lot of stuff in production, even now, is built with that stuff, but it's not with the new generation that's coming in. And I'm 100% all for this ease of use that's happening. I think that's the direction that the industry needs to go into, because you shouldn't need to have a PhD in mathematics or physics in order to build a model. It's ridiculous. So these libraries that are making it simpler, making it more easy to understand and intuitive, is what's advancing not the state of the art for our industry. It's advancing the opportunities to solve real problems with using these tools, because you're making it easier.
Yes, absolutely. But I would also kind of have an argument that that is a double two-edged sword, right? So
Mm-hmm.
on one side, you're making it very easy, and like a lot of people can start using it, like you said, right? Without CS training, without math training, and start using it. But in some places that becomes a problem as well, because a lot of I've seen a lot of people use um, machine learning models, scikit-learn models, without really understanding it, and that kind of doing it the wrong way, and it is not
Mm-hmm.
very apparent, but it's like if you know what they're doing and what they're supposed to do, you instantly realize that they're not doing it the right way. But then those kind of small gotchas and kind of caveats are probably that's I don't know, the price you pay for making it popular with the community. But
And
yeah,
I would double down on what you just said with another anecdote, which is I heard the same arguments 15 years ago when people were talking about the ease of use and explosion of applied business intelligence, where all of a sudden companies like Tableau come on the market, and it's like, whoa, it's so easy to do an analysis on fairly large data now. And the statisticians who were, historically doing this analysis in, a lot of them are writing code in Python 2.x back in the day, you know, doing sort of manual manipulations with a version of pandas that we wouldn't recognize today. The APIs were slightly different; it's a lot harder to use. But they're doing stuff with that, or they're using Excel with custom formulas in it, or they have some sort of
MATLAB.
BI tool, yeah, MATLAB or SAS, and doing analysis on these proprietary platforms. They saw this proliferation of BI becoming easier and more open to the layperson. And I heard the same arguments. They're like, the analysis are going to suffer, businesses are going to come to the wrong conclusion. I think it's a self-correcting thing. If a
Mm,
company allows people that are unskilled or untrained to do things that they're making decisions on, uh, they're not going to allow that to happen for very long, or they're not going to be a company for very long, because they're going to be relying on bad information. So nobody really talks about that in the BI world anymore. Like everybody can
mm,
use Power BI and Tableau. They're made to be as simple as possible, and anybody can make a fantastically terrible analysis with one of those tools. Whether it's like statistically and mathematically invalid, the conclusion is completely bonkers, or it's intentionally, a chart is intentionally done with a hidden axis that's not linear, it's logarithmic, and they're like making it seem like it's linear. So people are like, oh yeah, we need to do this to make sales. It's like, no, it's a misleading report. Uh, that does happen, and it's always since the start of easier APIs in the ML community, I've seen that happen at customers and stuff, where people are like, we got this model, it's perfect, it's a classifier, we're detecting fraud. I'm like, cool. What's your accuracy on that? Like, what's the area under ROC? And they're like, well, it's 100%. I'm like, oh, that's awesome, that's phenomenal. Your model's broken though. Like, no, it's perfect. Like, yeah, the labels in the training data, like, it's completely overfit to that because it's predicting what it already knows. Run it on some holdout validation. Oh, geez, it's 1% accurate on the data that's never seen before. Like, yeah, don't put that in production. That's not going to go well for you. So yeah, I mean, it happens all the time, but it is course correcting. People will see that once an expert comes in and says, that
Mm,
doesn't look right. Can you try this and just make sure before we release this? And then that's an education opportunity.
exactly. I've had many times. The first reaction that I get when somebody tells me that they got a 99% accurate model is that check your code, check the data.
Check your data. Yeah.
100 times, yes.
Yep.
That's like a big red sign.
I don't know. I produce 99% accuracy models regularly, so maybe I'm just really talented. But
I mean,
um,
there are some models. I did a training series at a previous job where somebody had asked me that, like, hey, could you provide training examples of models that you could get 100% accuracy on, or triple nine, 99.999%. So I generated some data sets that I would have the class do. We would build the data set in real time, and then it would run through the code that I was writing in real time at the head of the class. And one of my favorite ones was, let's predict if it's going to rain in the next 60 seconds. And the input data was, everybody looks out the window and tells me if the sky is blue or gray. And we would do that and have it run like every couple minutes. But like, all right, everybody, give me all your data that you collected over the last 5 minutes. Let's see, are we still accurate? Of course, it was like a cloudless, beautiful, sunny day. The first time that I did that, I'm like, see, we hit 100% accuracy. It's predicting 5 minutes in the future, and we're always right. So that's a lesson for people as well in the data science community. Think about your problem. Like, what is your training data, and when are you making the prediction, and what are you going to do about that? And should this even be a model? Should this even be created? Because it's something that you can take the data itself and say, what color is the sky right now? Okay, how quickly can it start raining in my geographic region? Um, if I'm predicting 5 minutes in the future, I can just say, yep, blue sky, no clouds. Don't think it's going to rain. Don't need my umbrella.
yeah, that I mean, maybe you should have done it on a gray day though. That could have been a better sample. But
That did do one, but I just adjusted it to say that the time scale that we were predicting in the future was really, really short.
got it.
It was like 30
0
seconds
seconds.
later.
Got
And
it.
so it's
Yeah.
like, hey, it's 100%.
Yeah. Yeah. I mean that tracks. But I also wanted to get into one more topic with Manu. He has recently written a book called Modern Time Series Forecasting with Python. Explore industry ready time series forecasting using modern machine learning and deep learning. So it has that classic, what is it, colon, a bunch more text. And so, Manu, I was wondering if you could elaborate a bit on sort of the latest and greatest deep learning models for time series, because Ben and I chat about time series quite a bit on the podcast, and we're big proponents of simple and like ARIMA or profit based types of models. So where do you see deep learning excelling, and what are those models?
Right. Right. So deep learning, there are some new work that's coming out of the again research community on deep learning for time series data, both on the time series forecasting side and the time series classification side. Um, although the individual papers that proposes all of these techniques do show that they do better than some other competing methods. But as again, like similar to tabular data, like time series data as well, there's no one model which does well in all data sets. It is purely up to the person who's working on it to kind of find out what works well. So I've seen deep learning work well than um, Arimas and Profits of the world in many projects. But one strong contender to that best model class is also standard machine learning models, which is basically our uh, like GBMs, XGBoosts of the world. They are very strong, especially when you're talking about global machine learning models. But I'll come to that since the question was about deep learning. So the a few models which really interested me and which which showed some innovation in the way that they're kind of handling the time series data or the temporal pattern. One is the temporal fusion transformer. I think it came out from Google's research. But then they had a very, although the architecture is quite complicated, it has many different parts in it. But there are some intelligent ways in which they made the whole thing work. So that's, and that model also performs pretty decently on many data sets. And another, there are two other models from the transformer, or at least modifications of the transformer model, which is called, one is called the informer model and the other is the autoformer model. Um, Again, both of them have very innovative ways of injecting the temporal kind of aspect of time series into the model, because although transformers were designed for sequence modeling, but it is predominantly for like NLP type sequences, right? You kind of you don't need to look at a long history to find out the seasonality which happens every 1 year, every 2 years, something like that. The patterns are more local and things that it's very I wouldn't say simpler, but the kind of the kind of focus is different. But then these guys, the guys who prepared or proposed Autoformer and Informer, did very intelligent ways of kind of making sure that again you can capture long-term patterns. Um, because uh, like with transformers, right? If you just increase the context size or the window of memory that you give the model, in theory, it should be able to find out given enough data. But in the real world, we have a lot of constraints about compute and things like that, right? So the more history that you put in, the attention calculation is quadratic, and it kind of explodes. So these guys have very intelligent ways of including longer history with lesser computation, and those models are also very innovative, um, and like they do perform better. But then I'm not very firmly on the deep learning for time series forecasting camp yet. I'm kind of on the fence because I've seen unreasonably effective uh, machine learning models, global machine learning models work very well. And um, so, as part of my previous organization, I've worked with a lot of different large companies in designing their forecasting systems. Um, and almost exclusively these days the number of time series that you need to kind of forecast are in 10,000s, 50,000s, etc. So in those scenarios, using global machine learning models have always been um, better performant, less computation extensive, intensive, um, less headache from the engineering side because you don't have like millions of models to manage. You just can manage a couple of models. So in all of those aspects, I've seen the global machine learning models work really well, and I did not really have a reason to go for deep learning models because these models were doing their job perfectly fine. I'm sure if I put some effort into it and then put some resources to getting a good deep learning model done, I might be able to do it. But in a implementation, you have priorities, right? You know that you want to have something working as like the point is not to get the best accuracy, it is to get the accuracy which needs to be there for the customer. So once you hit that threshold, you kind of okay say that this is the model which works well, which serves your purpose, and is reasonably easier to manage, and you don't have a lot of technical debt, etc. So in all of those aspects, I've not done a deep learning model in production yet. But yeah, but then yeah, there are okay. I missed another deep learning model which I like a lot, which is NBeats, right? That's something that was shown to be there is this M competitions, right? The M4, M5, now M6 just wound up. So these are basically international forecasting competitions, which kind of Actually, I think it's hosted by, I mean, have the strong backing of the international forecasters, the Journal of Forecasters, something like that. So they do this yearly or bi-yearly competition. So M4, by the time till M4, all the other competition was consistently won by your classical methods like IRIMA, exponential smoothing. Not uh, obviously there are other kind of modifications. I'm just classing it all together in a single class. And even M4 was won by a model from Slavic Smile, which is heavily inspired from the exponential smoothing model, but just basically put it into a deep learning kind of a form. It's kind of like a hybrid model, right? But ever since that M4 competition, all the other competitions have been consistently won by either a deep learning model or a global forecasting model, global machine learning model. And this NBEATS model was proposed. Um, oh yeah, the history behind that is actually cool because after the M4 competition, the conductors of the whole competition kind of concluded that all of these new age fancy models like machine learning and deep learning are not the best thing for time series forecasting. And the classical models and probably hybrid models is the future, and that's the kind of conclusion that was put forward. And the people who've proposed NBEATS kind of said that we want to have a purely kind of a pure deep learning model, and we want to kind of say that the kind of prove that this can work better than the all the other models which were part of the competition of M4, and which they did. Right? They kind of ran this data, the M4 data, through this NBEATS model, and this NBEATS model was able to perform better. Like if NBEATS would have been part of the M4 competition, they would have won that competition. So that was like a strong, I don't know, statement that was made, and then I think probably a lot of folks got interested and started working on this time series forecasting, the deep learning area. That's that's interesting. But yeah, probably another thing, probably, and this is the right place to kind of put this forward is that global machine learning models, which basically means that instead of training a machine learning model for each time series separately, you kind of train a single model for a whole bunch of time series together, right? To put it simply and plainly, that is the global machine learning model. And M5 competition and a lot of other competitions which happens on Kaggle and other ways, right? All the forecasting competitions have been won consistently by one of these global models, right? And that's if you ask me the future, I think right now I'm betting on global machine learning models and global deep learning models to some extent to be the next step in time series forecasting. And the book that I was putting forward, one of the main narratives in the book is also that you kind of start looking beyond Arimas and profits and exponential smoothing and see that there is a whole different class of models which works extremely well and which is more suited to current situations, right? Because I don't know, Arima exponential smoothing models all came out decades ago, probably 50, 60 years ago. And at that point of time, the quantum of data that we had was pretty less, right? And we did not have to, like back 50 years back, if you tell somebody that you need to forecast 1 million time series, they would laugh at your face. But now that's that's very, very real. So, and when you're thinking from that context, training, managing, and serving 1 million models is also a nightmare. So you would, so I don't know, quoting that popular meme, right? Modern solutions, modern problems. So we need to kind of go ahead and kind of adopt some of these new age techniques, which makes it easier in one sense to work with these large quantum of data.
Yeah, that makes sense. Yeah, I know that Ben has thoughts on this, specifically distributing time series. Um, you want to share?
Yeah, I mean, I've seen LSTMs attempted to be adapted to time series problems, and if, like exactly as you said, if the data set fits something that works well for that architecture, and you adjust that short-term memory, attenuation, you can get predictions for forecasts against back testing, cross validation for that specific type of data that perform way better than anything else. My gold standard, and it's purely through bias, it's one of the most challenging models to tune, in my opinion, is Holt-Winter's exponential smoothing implementation, which that was based on I think it was 1972 or something, that algorithm came out. But that thing, it's fantastic for discrete time series, where if you understand and you can decompose that time series and you tune it very tightly, it is fantastic. Um, but how do you do that for 5,000 forecasts? You're not fine tuning 5,000 models. I don't care who you are, not happening. Um, so stuff like profit works really well for uh, even untuned profit works pretty well for a different set of use cases, where an LSTM might kind of fall apart a bit, because you have to still tune that attenuation band. And if you don't do it properly, if certain real world data sets that have some sort of repeating pattern that goes on for a little bit too long, all of a sudden it's not going to respond at all to the forecast. It's going to repeat this pattern over and over and over again. Profit does that as well if you have certain types of data that go into it. Um, but in the global model perspective, I've seen the exact same thing that you've said as well, where what do you do if you have 10 million items that you need to forecast inventory for, of sales inventory globally? What if you're this massive company? What if you're 7-Eleven and you're like, hey, we need predictions on every product in every store in the world? It's like, all right, you got 4.7 billion models you need to build every week. Where are you going to run that?
Yeah.
So
Yeah.
for global models, you train it on all of this data and you give it, basically your exogenous regressor elements as part of that training set, where you can give that additional data and context to it. They work really well for these extreme scale problems. But if you were to extract just a single, well, from what I've found in the testing that I've done, you extract a single random set of forecasts of these discrete series from that global model that you're going to be applying, and then build a Holt-Winters or a profit model on those, and just do basic like Optuna based hyperparameter tuning on them. Just say like, hey, you get 50 iterations, that's it, I'm calling quits. You can't sit there and optimize for 10,000 cycles like you would in a competition, um, or as part of a white paper. You just, within realistic boundaries of production reality at a company, if you compare those to that global model, the discrete ones are going to beat it every single time on accuracy. There's no getting around that. You could be an order of magnitude more accurate, but it's that economy of scale problem. Like, how do you solve this problem? And like, people know how to do it. We have customers at Databricks that are doing this today, that are running 4.5 million profit models in production. But you need to spin up, 800 VMs and expose, 1,600 cores to this problem, so that computation is done by the end of the workday, so that you have your predictions out there for the next workday. And it's expensive. So the real trick is, how do you solve that problem where you need accuracy and you also need to store the model? Because there's industries out there, logistics industry is not one of them, but if you're in the financial sector or health and life sciences, or you're doing government accounting, or you work for a government somewhere, any model that you put out there for consumption has to be stored, because you could either be facing a lawsuit where that's going to be inspected, or you just need to be audited because of legal requirements by a government. So you need to store it somewhere. Um, so we actually solve this. We have an open source package at Databricks that we created for this exact use case, called Diviner, and handling that extreme scale for doing like profit models, where you need the accuracy, but you also need to store it. But you don't want 4 software engineers to work on this problem for 6 months to build all the infrastructure of like, how do I save 1 million models every day? that's what that package solves for people. And that gets tying back to your initiative that you're talking about, Manu, where it's like, hey, I need to take tabular data and run it through PyTorch. And I don't have a team of software engineers that can do this for me, because this sucks building this infrastructure. And I don't want to just build a bespoke implementation that just works for this one project that's built into my code, my project code. Thank you. The open source community thanks people like you that think of these things like, hey, this is a problem. People need to do this. It's painful to do it manually. It's way better to buy. It's better to buy than to build, but it's way better to free than to buy. So having it out there in the open source is great. And we feel the same way. That's why we did the same thing for this use case. But I do agree with you with the vast majority of extreme scale forecasting that's out there, where you don't need ludicrous accuracy. You don't have, for any particular decision that's out there, you don't have $1 million on the line. Like if you get it wrong, you lose $1 million. If you don't have that problem, or if you get it wrong, you kill somebody. If you don't have that problem, and you're just like, hey, I need to know within 20% margin of error how much milk we need to ship to this store 2 weeks from now. Like, because 2 weeks ago we shipped too much and we had to throw away 1,000 gallons. So if you just need that sort of thing, and you have, 1,000 stores globally that you're shipping milk to, and you didn't even know to tell the farmer, hey, we actually need about 10% less next month. So that excess that you have, why don't you go make cheese? We'll buy the cheese too, but we just don't need the milk. So being able to do that, those global models are great for that. And I completely agree that that's the way that people are going to start doing this to solve this problem, because it's way cheaper, it's way faster, and for most use cases, it's accurate enough.
Exactly. Yeah. And another thing is, I think I've seen this in retail a lot, right? So the retail demand has a lot is really influenced by their promotional activities and
Yep.
things like that, and that's not periodic, right? You don't
Right.
have the same things everywhere, and that's another area where a classical model does not really do well, which when I've seen, because Arimax, yes, to some extent, but
You can do
I
it. It's
yeah,
not
but
easy.
yeah, because it's very, I don't know, it's very unstable in one way. But whenever you get these kind of things, simply doesn't learn that well, or I might not have put that much effort into making that well as well. But in such scenarios, right, when the signal, when an external signal come, like really plays big part in moving the needle, then also these machine learning models kind of pick that up very very well, right? That's another area I've seen. But I agree to your point. Like if there is no other, if there is like a very stable kind of a time series, right? There is now like frequent peaks, everything. The classical models does really well. Kind of
Yeah.
even if you put a auto-tuned exponential smoothing, just run it for a few things, it will do well. I totally agree to that point.
Yeah. And that you nailed it right on the head with the complexity involved in when humans are manipulating in an unpredictable fashion your time
Yeah,
series trend.
yeah,
It's not something like, hey, it's holiday sale time, we know we're going to get sales to spike, and it happens every year around this time, different magnitudes and maybe slightly different shape of the actual regression curve.
yeah,
But
yeah,
when you start saying like, hey, we had a fire sale in August for some reason, and that's why we had this huge spike in sales, you have to either manually go in there and clean your data to say, hey, I actually need to remove all of these sales from that trend because it's synthetic, or I need to mark it. And then marking it means that's now an exogenous regressor term. So every other row or every other time period is a 0 and this is a 1, so that I can tell it to Saramax or Remax or any of the other exogenous regressor terms to do that. It's just easier to do that in supervised learning, where you're providing that vector into the training model. That's just another feature. and you can apply a weight to that feature and say like, hey, really pay attention to this because this is what this actually means, and the model will adjust to that. It's a little bit trickier to do that with certain types of models, I think. So I've seen people do global models with linear regression, like generalized linear regression, and they're like, well, that's what ARIMA is. I'm like, it's one part of ARIMA is a regressor, but there's other things in there. So when you're talking about these gradient boosted models where they can shorten the training time required in order to build those discrete regressing terms on each of the tree ends, it becomes a little bit easier to swallow that. And deep learning, I think, it adapts to that better. But to follow on for your point before, with deep learning where it is right now as global model solution, I'd say it's still in research phase. Like the papers are still kind of being written right now. Nobody's got anything that's really, nobody's got that Meta profit mic to drop right now with a like, hey, here's the architecture that's going to make this simple, and it'll work for 80% of the use cases that people want to use simplistic time series forecasting for. It won't work for the other 20% and never will. But I'm waiting for that day when that happens and it drops on PyTorch. I'll be doing an integration with that model, definitely.
I agree. I agree. That's exactly right. That's how I see it as well. Time series forecasting for deep learning is still very much in the research phase. You
For
can
now.
you can still use it for your curiosities, but yeah, yeah,
That's a good bit of advice as well. Never be afraid to try something,
yes,
but always try it before using it.
yes. And yeah,
Cool.
I think
Sorry, go
yeah.
ahead,
Sorry,
Manu.
no, I was just saying that in so time series forecasting as well, right? It's like very like we say that okay, there is time series forecasting, and then we probably go to the internet, look at a few tutorials. We'll see this airlines passenger data set which goes beautifully, and then you learn all of this. You go to a real world time series, you look at it, and you'll be like, what is this? I've
Yep.
not seen any of this in any of the tutorials that I've seen. And that's kind of like basically the one of the biggest gripes that I had when I started writing this book, right, was this, right? Whatever tutorial that you look into, or whatever book that you read about time series, um, all of them kind of start with ARIMA classical models, and they stop there, right? They don't go ahead, right? They don't go like they so they do okay. There is this model ARIMA, there is this model exponential smoothing, profit. This is how you use it, and that's it. But in my experience, when I was working in the industry with real data, uh, these set of methods work on a very small subset of the whole universe that you have to forecast, right? Your high selling, like in retail, your high selling, very smooth ones, they work perfectly. But that those are typically your 10%, 20% of your whole universe that you have to forecast. So I was kind of wondering, like, where are the tools, or where is the literature that talks about tools which can handle this large part of your time series or of your universe, which is completely missing? And
Mm-hmm.
that's why I think this is like a space that somebody needs to fill in. And that's the kind of initial thought process behind the book as well.
Yeah, there's no greater feeling of dejection than after getting like buying a book on this stuff or taking a course, and then you're working at like a retail or something, and somebody's like, we need to forecast the sales of Rolex watches. You're like, okay, yeah, that sounds like a great idea. And then you look through the database and you're like, we sold one in the last 3 weeks and they want daily predictions. What do I do with this? I heard profit works with missing data. You fit the profit model and that's going to predict that you're going to sell the equivalent of Rolex watches because there was 3 sales last week, all by one person who's a reseller. And then you look, oh, forecast next week is enough Rolex watches to equal the mass of the moon. So you're like, okay, maybe I need a different solution here. So yeah, Been there. That was early on in my careers with time series models, was just seeing stuff like that where you're like, I can't use ARIMA
Yes.
here, so I need to do something else, like predict, per day whether a sale is going to happen or not using a logistic regression model. And I just have this massive feature set based on all of the properties of, how many people came to a store, how many people logged in, what did they look at this day? And I can predict if, tomorrow somebody's going to buy one of these things. So you have to get like really creative, and it's not simple. But yeah, you can't
Yes.
apply a REMA to that because it's a null data set most of the way.
Yes. There's hardly any information, right? Like one spike in 2 weeks, and that's it.
Yep.
So
Let's predict the sales of Bugattis in Ohio. Yeah, it's not going to work out too well.
I
Not to
mean,
pick on Ohio.
have you
I'm sure
checked that Ohio doesn't purchase millions of Bugattis daily?
I have not checked. I don't have the data on that. I'm assuming, this could be a biased assumption, that there's not a lot of Bugatti sales in Columbus, Ohio.
I think that's a valid assumption. Cool. So we're at time, so I will quickly wrap. So we talked a lot about time series data and sort of PyTorch libraries and a bunch of other cool things. But some things that stuck out to me are that tabular data are data that have rows and columns, and PyTorch doesn't natively support tabular data. So Manu created a library called PyTorch Tabular that allows you to specify simple parameters like column names, types, and desired transformations so you can manipulate this tabular data. And then regarding open source tooling, if you want your project to grow, it's really useful to provide examples. It's also relevant that the majority of the contributions come from a small set of contributors, classic long tail distribution. And then also leveraging your network or other networks is sometimes a necessary component of growing an open source library. But the key under all of this is build something good. If it's not good, it won't get used. If it's good, it doesn't guarantee that it will get used. But if it's not good, you're done. And then finally, negative feedback is worth plus 1 million points. So, Manu, if people want to reach out, how can they get in contact?
all right. So I'm on LinkedIn. That's the platform I'm most active in. I think the link is in/Manu Joseph V. And I'm also on Twitter, although more of a reader than any posting. So again, same ID, Manu Joseph V. So these are the two places that I'm there. You can reach out to me. I'm always open for collaboration, talking to new folks, etc.
Great.
Please don't
Well,
put issues on his repo just to say hi. It's very distracting. But definitely check out his repo. It's cool.
Cool. Well, until next time, it's been Michael Burke and my co host,
Ben Wilson.
and have a good day, everyone.
Take it easy.